So hey guys, yeah, this is our project for our group. The group is Joyce, Paul, and myself, Sammy. So basically, um, well, because there's a lot of waiting in the demo, I'll just start things right away, and then when we're waiting for stuff in the pipeline, we'll go back to the presentation. So as you can see, we have here two EC2s, one for Airflow and one for Superset. There's one for Kubernetes as well, but we're running the project on Docker Compose for now, so we'll just concentrate on those. So the first step would just be to upload the banking CSV. That will trigger our Lambda function. We'll talk in a little bit about what exactly the function does, but more importantly, we can go here and monitor the logs and see the trigger. Yeah, here it is. So one of the things we try to do is to make like the Lambda function tell us what exactly it's doing step by step. So we're monitoring what happens. So like okay, the file has been received. We're starting Lambda function. One of the things that we automated is the Lambda function starts the EC2 instance for Airflow. So if we go back here, we'll see that it's pending, and we have a function that watches it. And when it's running, it's just going to wait for a bit for the Airflow containers to be healthy. Once they're healthy, it's going to parse the event from the S3 upload and continue with the process. So while we're doing that, we'll just continue with the presentation.
Do you want me to take Paul's part?
Sure, go ahead.
Okay, so our project focus, I'm not going to go through every single point of it, but the very main goal for this project is to learn as much as possible, making sure everything is working, at least for the skeleton first, and then we'll implement as many things as possible on top that we can manage. And we try to automate a lot of the stuff just so it is more streamlined and user-friendly, definitely minimize the cost, which is also good in real life. And next slide, please. And here's our system diagram, which is basically similar to many of the presenters today. We're also using pretty much everything in @ONE's code, where we're using the banking CSV file uploaded to S3 bucket, which will then trigger a Lambda to push it to Airflow with the Docker and EC2 machine running. The Lambda will also be monitored by the CloudWatch. And in the Airflow, it will then push to start the EMR using Spark to transform the CSV into a Parquet file, which will then save into another S3 bucket. And then the Airflow will recognize that and start the glue, which will create a crawler accordingly. And then Athena will be referencing that to get this data. And Airflow will also help to start the superset EC2 instance for BI purposes. The next slide is going to be the Airflow deck, which I won't go through them in details because in demo, Ahmed will actually show you how it looks like. So I'll pass it back to you, Ahmed.
All right, so let's see where we're at now. So by now, we should see that, yeah, so the Airflow machine is up and running and the connection has been established. So we can quickly open the Docker Airflow here and see the DAG is running. Let's check the progress. So the first part was just to get the S3. This was just the parser. We just renamed it, for ease of understanding. This part here, basically, Joanna will talk about in more details, but basically this gets the timestamp so we can use it to dynamically name the output folder that we get from the Parquet. Also, we have the AMR cluster running automatically. So this starts the AMR cluster. So if you go here, we'll see a new AMR cluster running. And one of the features also Joanna will talk about momentarily is we have the steps integrated into the configuration of the AMR cluster as it's being created. So we don't have to add anything. So of course, the AMR cluster is going to take a while to load and work. So I'll pass it back to Joanna to continue with the presentation.
This is Joyce, by the way.
Oh my goodness, sorry. Oh,
I guess you're so nervous, but it's okay.
Yeah.
On top of the basic pipeline that @ONE has taught us, there's a total of 9 new features that was added. Don't worry to read through all these 9 points because we're going to go over them one by one in the next few slides. Next, please. So the first one is elastic IP. So whenever we created an EC2 instance, we need to SSH into it and to maybe change a couple of things and update a couple of things. And in order to SSH into it, we need to use this public IP address. But every time when we start a new EC2 instance, it will generate a new public IP. And to avoid manually looking it up, we added the elastic IP, and then we associate that elastic IP to an EC2 instance, which will give the instance a fixed and constant IP address to use. Next, please. And in @ONE's basic pipeline, we need to click to start our EC2 instance before we start basically anything, like doing anything. In this automation, the EC2 instance for the Airflow will be triggered to start using Boto3 once Lambda is triggered by the upload of the CSV file, as you might have already noticed when Ahmed was doing the first part of the demo. Next, please. Originally, once you SSH into your EC2 instance for the Airflow, you'll need to start a couple of things. One of them is your Docker. One way to start your Docker is using sudo service docker start, but we use this sudo systemctl enable Docker, which will automatically start Docker whenever the EC2 instance has started. Next, please. After a Docker has started, there are a couple of Docker containers, just, I don't know why, for whatever reason, won't start itself. And there are mainly the Postgres, Redis, and the superset. In order to streamline them, we put the Docker start command line into an rc.local file, which is one of the default file in Linux of the EC2 machine. And these lines will be executed whenever the Docker has started. Next, please. After we have all the parts of the Airflow streamlined, we'll now look into the DAG, which is to help trigger the Spark transformation via the EMR cluster. In @ONE's code, we'll need to create the EMR cluster every time or clone it manually. But here we added it as part of the steps in the DAG. And once the transformation is done, the EMR cluster will automatically terminate itself with the keep job flow alive when no stop set to false, and there's some cost saving in here as well. Next, please. When we have our EMR cluster started, we will need to get its cluster ID and manually update it in the DAG. And here we again put them as part of the config, so it will be included as part of the Airflow step, and this also eliminated the need to do the step editor in the original code in the Airflow step. Next, please. One issue that we have when we're doing the basic pipeline is that after the transformation is done, and when it's trying to save the Parquet file into S3 bucket, the output folder won't be overwritten on its own. So we decided to use this timestamp, which we already saw in when Ahmed was doing the demo. In one of the very first step, there's a timestamp that we use to log, and then we'll put that into the folder name. So we're using an xcompose to do that, which, the DAG step is actually called record time just now. Yep, next, please. So once these are all done, we'll start creating a glue crawler. As we all know, the glue crawler will actually reference back to where the Parquet file is stored. And since we have that ever-changing dynamically named output file, we don't want to update it manually every single time. And here we use the Boto3 to create the glue crawler, and then use xcompose to get the changing output file name to streamline the process. Next, please. Last but not least, once we have our glue set up, we'll need to start the superset. And here we use Boto3 to start the superset EC2 instance, so we don't need to create them ourselves. Now I'll pass it back to Ahmed to finish up the rest of the demo.
Thank you very much, Joyce. So let's check on our progress. So looks like our EMR is still trying to run here. One quick thing I'll mention here is we're actually using this class here, which is used for computation. The M5 is used more for general use. So we opted for that not only because EMR is meant for mainly computation, but also we found that the demand on these, it usually takes a lot less time to provision these. So that's why we opted for these particular EC2 instances. Oh, so it looks like it's running just now. We'll give it time, but as we wait, let's go back to the presentation. So just quickly, I want to talk about the challenges that we faced in this project. So whether to use Docker Compose versus Kubernetes. So basically, we spent a lot of time learning both, and we had a lot of challenges with the Kubernetes version. I'm sure the TAs and Edwin will know because I messaged them so many times about this. And turns out because the Kubernetes version has so many layers and so many nuances, especially because it's using a previous, like an older Airflow version, like Edwin mentioned earlier today. We opted in for using the Docker Compose because we couldn't implement all the features we wanted in the Kubernetes version. We still got it running on a basic level, but it was much easier to work with Docker Compose. Of course, we were limited by the time, so we had to cut a lot of things that we wanted to add. And most of our team, I mean, all of our team actually were not experienced with a lot of the components, especially something like Airflow. We almost had no experience with it outside of the course. But by the end of this project, we learned a lot about this. And that takes me to this slide here, which is, for me, this is the most important part of the project, is what we learned, because as Joyce mentioned in the very beginning, our main focus was to learn new stuff. It wasn't to, present cool looking data. Not that it's not something important, but for us, we're really, eager to learn stuff. That's why, for example, even though we didn't end up using the Kubernetes version, we are really happy we took a lot of time on it, because we learned what Fluxity is, what Helm is, how to use them, and things like that. And of course, all the other things if we knew them, we got a lot better at them. A quick list of the features we wanted to add. I'm not gonna go through those just for the sake of time, because I also wanna show the rest of the pipeline and leave some time for questions. But there's a lot of features that we wanted to implement. For example, with Athena with a superset, we wanted to. So you'll see that the last part of our DAG is just to run the superset EC2, but we don't automatically connect that superset to the newly created database. So that's something that we want to do, for example. And also we have the repos available for anyone to check if they want to see the code and ask us anything. But before I open the question, let me actually show the rest. So we can see here that we successfully got the output path. Basically, the unique name here that has been created with the timestamp with today's date and month, and the GMT timestamp. And we gotten that. So also EMR was successful according to this operator here. We've created a new glue crawler. So let's go to glue and check out the crawlers. And you'll see, so the unique name we had for the run had this timestamp, 1211. So you'll see 1211 1624, right? So you'll find that here. This was just created now. Actually, it's just running now. When it's done, it should create a new table, and then we would have a new database with the unique name with the timestamp. Once that is done, then a superset machine starts automatically, and with the Docker service and containers running automatically as well, you can just go to the interface and check things out. Unfortunately, we didn't have enough time to do any fancy analytics. So these are just the basic graphs that Edwin had in the original pipeline, and they are using the original output folder. That wasn't just created, but the original one, because we haven't automated basically connecting superset to the data yet, to the new database. But just for the sake of time, I'm gonna end it here and open the floor for any questions.
Good. I think it's good work, guys. Can you go back to the DAG? I just want to see. So the record time, sorry, I missed the time and the guide S3 file path. Like, what's the combinations of those two, before starting the EMR cluster?
So of course, these are running in parallel. This just gets the timestamp in. Originally, we had like a variable just in the DAG code that gets the timestamp. But when we researched it further, we found a lot of advice about if we're going to pass any variables, we better pass them through airflow steps, right? So we created an airflow step just to get the timestamp, and that will be used later to when in the Spark steps, that will give a dynamically unique name for the output folder. So it doesn't, because of course, if it's the same name, the Spark will just have a problem. And we're assuming like we're adding different files, maybe with the same name. So we'll still have all the data there.
I see. Okay, makes sense. And John, could you please help me, just remind me, like, let's get a session having the newer versions of Helm chart with Airflow in Kubernetes. Let's have a session for that. And it's my promise to you guys that we will for sure visiting these topics in the near future, for the next term.
No problem.
Thanks, guys.
One more quick thing, we actually had another step to close the Airflow EC2. We have the same idea, just like Pete, basically about cost savings. So we only run the EC2s if we need them. So we originally had a step here to stop the Airflow EC2, but it wasn't good for the presentation because, of course, the Airflow would crash immediately and we wouldn't be able to show it. But we have it in the original code. It's commented out.
Yeah, I mean, did you guys chat about it? Like, I was just seeing like for Pete and Joanna and you guys are like doing a lot of automations, and did you guys chat about it at all, or did you just happen to be you guys are thinking about automation for the different components within the pipeline?
I think mainly it was a coincidence, but Pete and I talk a lot during the TA sessions, so we might sometimes bounce some ideas off each other. But I think most of it was a coincidence. But we're both like, when we talk, we always both want to automate things. So it's just the way we think similarly in general, anyway.
Yeah, nice. I mean, I think it's very important. Characters being an engineer is trying to automate as much as possible. Yeah, but good job.
Thank you very much.
Any other questions from any other folks?
No comments, but like no questions, sorry, but comments. Like, yeah, great job, guys. Yeah, I know, Semi, you struggle with Kubernetes, but I think it's gonna pay out eventually. Yeah, that's, I think, nice projects. Thank you, guys.
Thank you,
Yeah, nice.